All right, let's see if we can answer this question out of 11.2. Does f of x is x squared have an inverse function?
No.
No.
Yes. No. No. Yes.
Merely the fact that I'm asking this question implies that the answer is
No.
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 Yeah. Show of hands for no. Show of hands for having a good reason other than psychology for that. What's a good reason?
Well, because a function is inputs and outputs,
Okay.
and
Okay. So a function is a rule, right? Associating inputs to outputs, right? Is that all it is?
All inputs must have a different output.
With each input
Having only one output, right?
associated to one and only one output. You guys remember that? So if I draw x squared on here, right, I have a rule for taking a graph and turning it into the graph of an inverse function, right? Okay, so here's a kind of crummy approximation of x squared. Oh, actually, that's better than my previous one.
pretty good. I like it.
And now I should flip this picture over what? What were we flipping over? Yeah, we were flipping over the line y equals x, which I had in maroon on this picture earlier. Right, this line. It goes from the bottom left corner to the top right corner. So to flip over that, we go like this.
Problem.
What's the problem?
Vertical line.
Yeah, this thing, right, the result, fails the vertical line test. You guys see that? Okay, let me illustrate a little bit what that vertical line was, right? So here's a vertical line like the one that's causing me problems, right? There's my issues. You see what those are supposed to be? So let me go back to the original. So here's back to the original. What did my vertical line turn into? Horizontal line. Yeah, so to test if something has an inverse function, right? And this is really a thing called the, creatively enough, horizontal line test. Right, which is a lot like the vertical line test. Because it is the vertical line test run on the flipped over picture. You guys see that? So the horizontal line test says if any horizontal line hits the graph of a function f at more than one point, you guys see that's my two blue circles over there, right? So if the horizontal line hits at more than one point, then what? Yeah, then f, right, has no inverse function. Does that make sense? So let's talk about that square root thing for a second, because that's really a reasonable thought, right? I would look at f of x squared, think about inverse, and I might really think, hey, but what about the square root? Wasn't the square root the thing that undoes squaring? Yeah. When we flipped it over, we had kind of a problem, right? That there were two answers. There was a positive one, right? That's square root of x, right? That function we know and love. And then there's a negative one, right? You guys see that? Yeah, so that other thing, is negative square root of x. You guys see that? So in undoing squaring, right, there's two answers. We just picked, we said, okay, look, I want to undo squaring. I know it's not going to be a function, right? It's going to have two answers. So I'm going to make a function for one of the answers. That's that top half, right? That's square root. That's as close as we could get to getting an inverse function. And then we're going to say, oh, hey, and if you want the other answer, you do minus that. You guys see that? So plus minus square root isn't a function because it's two things. But square root is a function. It's just not the inverse of squaring. You guys all see that? It's a really super subtle thing. That's why we always have these problems when we're doing even powers and square roots or fourth roots or whatever. Right? We always have that problem with signage, and it's coming out of this picture.
So what would that equation look like? Would that, with the square root of?
Yeah, so there's two equations here. There's like f1 of x, maybe let me call it g for ease. So there's g of x is square root of x, that's the green. And then there's this other thing, like h of x is minus square root of x. Each of these by themselves is a function. And together they undo the idea of squaring, right?
Yeah.
But individually, neither of them actually undoes squaring, and together they're not a function. You guys all see that? We're going to run into a lot of things, actually, that have horizontal line test failure. They're not super hard to draw, right? You can see that? You want to take a second and draw something that fails the horizontal line test?